Hello everyone, I'm Matias Cavassa, joining you from Argentina. I'm part of the Power App program Cohort 24, and I'll be showcasing the Power Platform solution I developed to tackle this final parking challenge. Basically, the solution is designed to help Contoso High School staff to manage parking requests, carrying out inspections, and ensure the optimal use of the parking area, of the parking spaces. And with this video, I will demonstrate how each component of the solution addresses the required deliverables for the challenge. So I've been requested to create a new publisher. In this case, as you can see here, Matias Cavassa publisher. By clicking on the three dots and go into settings, we can see the publisher I created with a prefix MC, and here we have a preview for all the objects that might be created. So every single object, either a table, a column, is going to have this prefix with my initials MC. That stands for Matias Cavassa. So with that being said, and without further ado, I'm going to get into the solution. In this case, we can see the objects that are part of the solution. We have three tables beyond the tables that are coming by default in the Dataverse. We have parking inspection table, parking requests, and vehicles. That are the tables I created. In terms of automation, I created a cloud flow to send an email just after a request is submitted. And then we have two apps, a model-driven app that is meant to be used either by a requester. In this case, it's a high school. It would be a teacher or external visitor who wants to request a parking slot. And after the request, an email is sent. And also, it could be meant to be used by a staff member on behalf of the requester. So also, the staff member can track on all the parking inspection lists or views. So we also have a Canvas app that is meant more for the inspector, who is going to be in charge of conducting the inspections at a specific time. In this case, it's 5 p.m. So they would be able to take the data with either a tablet or an iPad or a phone or whatever. In addition to all these objects, we also have a Power BI model with different pages. This is the model. I brought in two tables in this case, a vehicles table from the Dataverse and the parking inspection tables from the Dataverse as well. And also I created a dim table, a dimension date table in order to leverage all related to time intelligence. Also I created a empty table to store and organize all the measures in this case we have. So with that, we have covered the core purpose of the solution and the main deliverables requested by the challenge. So now we are ready to jump into the technical step I took to meet these requirements. I'm going to start the walkthrough with the tables. In this case, we have, as I mentioned, three tables. The first one is the parking inspection tables. We can see here the table properties, the schema, and some data about the columns. And here we can see we have both. We have imported data coming from a CSV file, and also data that has been populated using either the Canvas or the model-driven app. So looking into the columns, and by typing in here in the search box my initial, we can filter the columns I created by myself. Here we have the lookup relating the parking inspection to the parking request and the vehicle name, and we have here this parking inspection as a unique identifier. It's going to be used later in the Power BI report to link directly from our report to our forms. The same structure for the columns in the parking request, and just for demonstration purposes, looking into the vehicles table and looking into the relationships, we can see the relation created using the lookup values and the lookup fields. So we have one-to-many for the vehicle's name and parking inspections. That means that one vehicle might have one or more parking inspections, and the same for parking requests, one-to-many relationship. Now pivoting to the apps, we have both apps we have created. We were requested to create. In this case, the model-driven app. I'm gonna get into it, and we can see all the data here by picking data. We can see all the data related to our app. In this case, our three database tables. Going back to our pages, we can see the three pages we have created for our model-driven app, including our vehicles view, our main view that is coming by default. And for the vehicles form, we have created kind of a header, and in the main container we have the vehicles data and also subreads relating data or pulling data from the parking request and the parking inspection tables. So we can get into this form either by clicking on new or creating that. That's the form meant to be used for, basically to create new records or to modify existing ones. In this case, if we want to modify the first one, here we can see that we have the vehicle data, all the parking requests created by this vehicle. This is a one-to-many relationship, one vehicle, many relationships, and the same for inspections. And in some cases, we don't have a parking request made in advance when the inspection was carried out. So for parking request views, we, in addition to the one that is coming by default, we have an active parking request today where we are applying different filters to just take the parking requests that were submitted today. In this case, I've submitted two today, 14th August, and and we can see that the same for parking inspection view. We have a parking inspection view for today inspections. So basically the same. We have the form to submit new parking inspections throughout our model-driven app. Now going into our Canvas app, tailor-made to be used by our inspector. In this case, as you can see, we have a home screen, 4 screens. In this case, a home screen with 2 buttons in the main container, allowing us or taking us to our review screen and to the new inspection screen. In this case, the review screen has a gallery pulling data from our parking inspection, so it's sorting and listing all the inspections from today. So that's the reason we have created that view I previously mentioned. And here we have a signal for invalid parkings. So in this case, we don't have a request in advance, and that means that it's an invalid parking request. I'm going to click the preview just to play around with the app a little bit. So you can see we have the review screen and the new inspection. If we pick a vehicle, in this case, it's taking automatically the parking request that is related to this vehicle. If we submit this, we are going to have that in addition to the 2 I was showing previously. So that being said, we can move to our automation app. In this case, when a request is submitted, we have a trigger coming from our database, Dataverse. In this case, when a row is added to in our parking request table within our organization scope, the flow is triggered, sending an email to the requester. In this case, we are also getting the vehicle's name from the Dataverse, and we initialize 3 variables. We capture the parking request ID that is being created at the moment the request is submitted, the request date, and the vehicle name. Then we have this function to capture all the requests for that time frame, for that specific date. And then we have a condition after that that is checking if the amount of requests for that date is less or equal to 15. It's going to be true, sending a confirming email. Otherwise, it's going to be false, and it's going to be declining the request. This is the recipient. That would be the owner, the email, the vehicle owner email. In this case, I place in my personal email just for the demonstration purposes. The subject is parking request decline. And here are the variables we have captured previously. So this is the body. Unfortunately, all 15 parking spaces are already allocated for today. Please try again tomorrow. And this is the body for the confirmation. So now we are ready to go to our Power BI report, where we have 2 cards. In this case, at the top we have a card that is summarizing the valid parking request. In this case, it's 90%. For the data we have filtered, 174 inspections. It's another data card. Here we have a bar chart to see data over time. In this case, inspections, we have false inspections, that would be the ones that doesn't have a request in advance, and one with true. Here we have a table with all the vehicles, and here we have another table with all the requests. By clicking on this URL icon, we can get into the request ID with all the data related. It's all integrated. We can get into the vehicle as well. In case we have, here we have all the history, all the parking with the subgrids I previously mentioned. We can choose and interact and upload a picture to this particular vehicle and send by close and update our Dataverse. By clicking here, we have the homepage of our Power BI report. We can interact with this fully synchronized filters page. We can release all the filters and going back and see that we have all the data included now. So we can improve this solution as an extension. We can include the request table into our Power BI model, not to just following up and keep track on the inspection, the valid inspection, but also to check on those parking requests that were made, but the vehicle or the owner finally didn't show up. So that, in addition to some kind of add more automations like triggering emails after the inspection, just to communicate that you made a request but you didn't show up, or you didn't request and you finally park or use a parking slot, just to enhance the compliance and that. This is a powerful tool and is providing the frontline workers with these capabilities and this software to develop low-code solutions with apps fully integrated with Dataverse is amazing. I fully recommend this, and I will be sharing this with all my colleagues here in Argentina. Thank you, and see you in the next challenge.